Okay, again, the most difficult thing for me is, reading the problem, understand what they're asking me to do. Find the number of shot in a truncated pile of 10 courses with a square base. If the number of a shot in each side of the lower base is 16. So you're starting out with 16 squared. Then the next one up from that is going to be 15 squared. And the next one up from that would be 14 squared. Right? And then you have to understand there's going to be 10 courses over here. Course 1, course 2, course 3. Let's keep going. And I'll count them for you, don't worry. 16, 15, 14, 13, 12, 11, 10, 9, 8, 7. I'm going to count these for you one at a time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 levels. That's the courses, by the way. All right? So it says find the number of shot. Well, I got to add this together, which is not the worst thing in the world to add together. There's many ways to do it, but we're certainly doing the Wells technique. So I'm going to write this a little bit differently because it looks a little bit odd the way it's written out, big number to small number. Let me write this down as 7 squared. Whoops, sorry about that. I'm going to say the set, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared. I think you get the idea. I'm going up to 16 squared. All right? What's A1 is 49. Let's do the differences. And, I realize that sometimes people say, these are really tough to compute. You're allowed to use a calculator. This is the first set of differences. So 8 squared minus 7 squared is 15. 9 squared minus 8 squared is 17. Let's see, 10 squared minus 9 squared. Let me write that down for you. It's not a bad number, but I want to point out the way some people do that is they say 10 minus 9 and 10 plus 9. That's how they do the computation. And what's that going to be? 19. I think you get the idea. Now, if you did 11 squared minus 11 squared minus 10 squared, right? What's that going to be? 11 minus 10, and then 11 plus 10. It's got a really kind of simple pattern to it. 21. I think you get the idea, right? It's going up by 2. 15, 17, 19, 21, 23. You get the idea. It keeps going on. Now, what's the D1? 15. Let's put down the differences too. Really simple. What do you get? 2, 2, 2, 2, yada, yada, yada. What's D2 is 2. All right, let's look at the key. Certainly we wrote this down here. Whoops, sorry about that. We wrote down this, we wrote down this, we wrote down this. By the way, I didn't put that difference through because I know it goes to 0. All right? What's the question again? Find the number of shot. All right? So what do we do? Well, we're going to add together. S1, S2, and then we got to do, let's count it up. We're doing 10, right? Let me show you what I mean by that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10, all right? So what do you get over here? S10. This is what S10 is over here. I'm going to write the formula down now, Sn. What's that going to be? And it goes on, but this is the formula over here. It's going to peter out, though. When does it peter out? Well, let's take a look at it. At D3, D3 is 0. So we just go to D2. So S10, N is 10. What's A1? If you don't remember, it's 49. I wrote down 7 squared instead. 10, 10 minus 1 over 2 factorial. What's D1? 15. 10, 10 minus 1, 10 minus 2 over 3 factorial. We got to go to D2. What's D2? Is 2, right over here. The other D's are going to be all 0, so all those terms disappear. And again, the expectation, you do the computation. And I really mean that. You do this computation over here, and you'll get this number over here. Are there other ways to get it? Of course there are, right? Pretty sure I didn't make any mistakes there. I'm not checking the numbers, though. You can check that if you want. If you feel I did something that's incorrect, though, please reach out to me. My name is Bannon, Ron Bannon. My email address is also Bannon, B as in boy, the @ symbol, NNON.US. Thank you.